We present tracing versus freehand for evaluating computer-generated drawings. The computer graphics community has long been interested in developing methods to approximate what people draw. Computer-generated drawing approximations are often used as a proxy for hand drawings. However, the extent to which current CGDA results resemble real drawings remains unclear. In particular, most CGDA methods only approximate the end result, neglecting the drawing process, which includes stroke and temporal information. We consider two common forms of drawing, tracing and freehand. Tracings are easier to obtain than freehand drawings and are registered to images by definition. The art community has long discussed the distinction between them, but there is a lack of quantitative analysis. There have been quite a few datasets that provide insight into drawing, but they are not readily applicable to the comparison between tracing and freehand drawing. In our study, we included 100 photorealistic images with wide variations in appearance and content as prompts. We collected 1,210 tracings from 96 participants and 288 freehand drawings from 19 participants. We register freehand drawings using a coarse-to-fine optimization of image correlation between freehand drawing and tracing density using ITK. We start our analysis by exploring whether people trace and draw similar content using rasterized drawings. In both tracing and freehand, over half of pairwise distances are within 4 pixels. This corresponds to commonly drawn content such as contours. About 15% are 20 pixels or more, which represents strokes distinct from each other. We found that in both tracing and freehand, people tended to draw more common pixels early. People preferred finishing the entire outline first in tracing, as opposed to decomposing the prompt into parts in freehand drawing. The raster representation showed what people draw in common, but it missed stroke information. We now look into whether people use similar strokes using recorded vector data. We extracted a list of stroke features and examined how they changed over time. We found that in both tracing and freehand drawing, early strokes tended to be long and drawn slowly using opaque colors. Late strokes tended to be short and drawn quickly using translucent colors. Next, we examine whether tracing and freehand drawing evolve similarly. We labeled strokes based on drawing intention and observed that drawings progress similarly in tracing and freehand. Silhouettes were dominant at the beginning, and hatching strokes became more prominent towards the end. Such trends suggest the possibility of stroke classification using stroke features. Here we show sample labeled tracings used for training random forest classifiers. The classifier trained on tracings not only performed well on other tracings, but could also be transferred to freehand drawings. After comparing tracing and freehand, we now evaluate how much current CGDA output and hand drawing overlap. We found about 60% of drawn content is consistent with computer-generated output. As shown here, NPR methods captured contours but did not consider texture information. Some image processing results contained incomplete or extraneous edges. Compared with CGDA results, drawings were cleaner, more organized, and contained interesting strokes that depict tone and shading. Finally, we examine how CGDA corresponds to current strokes. For each stroke, we computed the common score and the CGDA score. We can see that early strokes tended to have higher common and CGDA scores. A correlation analysis suggests that CGDA can capture content that people commonly trace and draw, but not their diverse artistic conventions. To conclude, our analysis reveals the similarities and differences between freehand drawing, tracing, and computer-generated drawing approximation. Tracing is similar to freehand drawing in temporal tendencies and representation choices. Spatial temporal stroke features can characterize drawing intention in both tracing and freehand. Current CGDA results only capture 60% of drawn pixels on average, highlighting the great value of collecting hand-drawn data. Our dataset and analysis can be useful for many future applications, such as translation between image and drawing density, data-driven NPR methods that better emulate the drawing process, and recognition of different types of strokes and their customized treatment in sketching interfaces. Thank you for listening.